Okie spokes, let's jump into some reasoning all about measurement of angles. Okay, these are going to get progressively more challenging as we go through. Some of them are going to actually be quite difficult questions. You're going to need some careful thinking. Question 1, we have Layla completing 1.5 somersaults in a dive. Again, all sorts of clues in the text here. 1.5. We've got a somersault. If you don't know what a somersault is, you can kind of work it out from here. Here she's facing upwards. Here she's facing upwards. That means she has done one full turn, and then she does another half turn to go from here to here. So we've got a full turn and we've got a half turn here. A full turn we know is 360 degrees. And a half turn we know is 180 degrees, which is half of a circle. If I add those two together, I get a total of 540 degrees of rotation, which is 1.5 turns. Any gymnasts or skaters out there might recognise those numbers. 360, 180 gives me a combined 540 total. Okay, circle the pentagon with exactly 4 acute angles. So we're looking for exactly, we're looking for those acute angles, and it has to be a pentagon. Right, this bit here is going to be my kind of first thing to have a look at, because pentagon 1, 2, 3, 4, 5, pentagon 1, 2, 3, 4, 5, pentagon 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. That is not a pentagon. That is not a pentagon. Okay, common sense check. Basics, basics, basics. Count them. So now I've only got 3 to look at instead of 5. Acute angles. I can see from looking at all of these, and we know from our knowledge of a regular shape that in a pentagon that is not going to have acute angles. Here, 2 of them are demarked as being 90-degree angles already. So if those are 90 degrees, by definition they cannot be acute. Also, through inspecting these angles here, we can see quite obviously those are greater than 90 degrees. Those are obtuse, not acute. This leaves us with only 1 acute angle in this shape, so that one, no thank you. That means that this one is our only realistic proposition left, so this one should be the answer. Let's just double check that, shall we? Okay, we're looking for internal angles that are acute. So I believe that one is, I believe that one is, I believe that one is, I believe that one is. The way you can check that if you don't have a protractor is you can simply draw yourself on that remainder of what would be that inner square. So that would be my 90-degree angle from those corners. And because the internal angles are less than that, that means that they are acute. Here again, if that was my 90 degree there, you can see this angle is less, so these are acute. And you see, because the shape's a reflection itself, that's going to be the one that's correct for this one. So in terms of this one, that is what we need to do. Actually, I need to circle it, didn't I? There we go. Okay. Question 3. Calculate the size of angle A and B in this diagram. What we need to know here is this fact about opposite angles. So last time out when we were looking at angles, we looked at Z angles, where we have 2 parallel lines and a line going between them. And we looked at, there's an interesting fact that this angle here will be the same as this angle here. Okay, and similarly, the angle that's made with the straight line here is going to be the same as this angle here. So that was really helpful for that. It's not massively going to help us here. So what we need to know here is about opposite angles. And actually, with opposite angles like this, where I have 2 straight lines crossing, and they continue to be straight lines, angles that are formed opposite each other are equal to each other. So angle A is simply 160 degrees. Okay. Now, I've got some other facts that are given to me here without being really told about them. They're like hidden facts. Both those corners there are right angles. That means that both those corners there are 90 degrees. So I've got a 90, I've got a 90, and I've got 160 for A. The only other bit of knowledge that I need here for shapes is the fact that if I identify this shape, it's getting a bit messy, I know, so let me rub out those bits. If I identify a shape here and I go for one of these, let's go for this colour. Let's just outline this here. So I've got 1, 2, 3, 4. This shape here, ignoring the left hand side of my diagram, this shape here with the angles A and B inside it is a quadrilateral. One thing that we need to know for quadrilaterals is the internal angles of a quadrilateral add up to 360 degrees. So I need 360 degrees total. At the moment I've got 90, 90 and 160. So I've got 180 and 160. If I add those two together, whatever's left between these internal angles and 360 is what I have left to be angle B, because it can only add up to 360 degrees in total because it is a quadrilateral, it is a four-sided shape, so the internal angles must add up to 360 degrees. Okay, so 90 plus 90, 180, 180 plus 160 gives me 340. 360 to 340 is 20 degrees, which means that angle B is 20 degrees. Okay, and you can do a common sense check on that. You can add them back up. Look, if I put 20 with 160, that makes 180. 90, 90 makes 180 as well, so that's going to get me back to 360 degrees there. Okay, opposite angles and then internal angles of a quadrilateral is the knowledge I need to know in order to work this out. Okay, and then it simply becomes as difficult as working out the difference between 340 and 360. Question number 4. This is bringing in exactly this Z angle that we've just spoken about here. You can see actually that's a pretty good model of this one here. So if I identify my Z angles here, let's use this colour. We'll go along here. Here's my Z angle on this one. Okay, and through looking at that, I know that angles that are found opposite on here are going to be the same. So that means that if I use this colour, this angle here, where it says 34 degrees, is going to be the same as this angle here. And it's going to be that because these two lines are parallel. Okay, how do I know these two lines are parallel? A couple of reasons. 1, it's a rectangle. 2, my opposite corners here are 90 degrees, which means these lines have to be parallel. Okay, because otherwise it's not going to work. So B is as straightforward as saying, well, that's 34. Okay, because of my Z angles, that means that this angle here is going to be the same as this angle here, as A. That doesn't really help me. So what is going to help me for this one? Okay, well, let's get rid of this. If I now know that B is 34 degrees, I know that here this is 90 degrees because it's demarked as a right angle, and I know that the internal angles of a triangle have to add up to 180 degrees. So if I add up my right angle and I add that to my angle B, 34 degrees, I get 124 degrees. Now all I need to do is I need to do 180 subtract 124, which will give me angle A, which gives me 56 degrees. Common sense check with that is I know that I've got myself a little triangle here. Let me show you that triangle, and if it's not clear, I've got myself a little triangle here. Make it a bit bigger. Here. Oh, I don't want the arrow end on it. What else? There's my triangle, and those are my 3 internal angles, 56, 34 and 90. They add up to make 180 degrees total, so that's correct. Okay, a couple of things. Where it says not to scale and where it says do not measure the angles means that this is a reasoning task, not a measuring task. These kind of diagrams will have been specifically drawn so that angle A and B are not actually 56 and 34 degrees. If you measured them, they're not going to be those measurements. So if you actually measured them in a reasoning test, you would get the answer wrong because the question is asking you to reason and work out what the angles are using knowledge of shape rather than your ability to use a protractor. So it's just worth bearing in mind. Look for those bits. If it asks you to measure it, measure it. If it asks you to calculate it, don't measure it. Okay, question 5. Survey of children's favourite fruit juices. These are results. Percentage of children. So we're looking a little bit at percentages. You'll see in a sec how this gets into work on angles and degrees. This jumps out as me. Okay, Apple jumps out at me straight away. 25%. I don't know if it's going to be important, but I know straight away that that is a quarter. I know that orange is less than a quarter, grape and mango are both more than a quarter. If I add all of those up, I'm going to get myself to 100%. 30 at 31 at 25 at 14 makes 100, so that's 100%. So I'm not missing anything from my survey, which is fine. Okay, let's look at the question. It says 20 more children chose grape than chose apple. So here I have grape, and I've already circled my apple at 25%. So interestingly, what do I spot from that? Well, I notice that the difference in those is 20 children, but I also know that the difference in those is 5%. Okay, if the difference between apple and grape is 5%, that means that the 5% is equivalent to the difference in the number of children between them, which we're also told here. Okay, so 20 more children chose grape than apple. Okay, that's 5%. That means that 5% of my total is the same as 20 children. Okay, because 5% more chose it and 20 more children chose it, it means that 5% is 20, which means that 5% of my total is 20. Okay, so then all I need to do is I need to go, okay, well, if 5% is 20, how can I work out 100%? Well, it's fairly straightforward really. To get from 100% to 5%, I divide by 20. So to get from 5% to 100%, so if I go from 5% to 100%, if I want to do that, I just need to multiply by 20. Okay, so that's how I get from that, because 5 times 20 is 100. Okay, so all I need to do is I need to take my number here of 20 children, which is from up here, which was 5%. I need to multiply that by 20. So I'm doing 20 now times 20, and that's going to give me my answer for 100%. Okay, 20 times 20 is 400 children. Okay. Chen makes a pie chart to show the results. What angle should he use for the children who chose mango? Okay, so I'm going to bring that information down here. Mango was 31%. So let's come down here. We're looking at 31%. I'm just going to write that down so I've got that to hand. Okay, things to know. That in a full circle, in a full circle, we have 360 degrees. Okay. Interestingly, we've got apple already on here. Now, apple here, look, was 25. That was a quarter. That's a quarter of the circle here. Okay, which is also 90 degrees. Okay, that should give you some clues. It's not going to really help you answer it, but it should give you some clues. What I need to know here is in a full circle is 360 degrees. Okay, so a quarter of that is 90, which is why I have my apple down here. So what I actually need to now do is I need to find 31% of 360. And that will tell me how many degrees I should use. Okay, so if I want to find 10%, I divide by 10. Okay, so 360 divided by 10 is going to give me 36. So 10% is 36. Okay, because 10% is 100%, 360 divided by 10, 36. Alright? So if I want 30%, I need to take my 10% and I need to do, okay, well, if that's 10%, if I have 3 lots of 10%, I'm going to get 30%. Okay, so 10% times 3 is 30%. Makes sense? Okay, so then that means that 36 times 3 is going to give me 30%. Now 36 times 3, you would use a method for doing that, or you'd use your mental skills, is 108, so that's 108 degrees. However, that gives me 30%. I don't want 30%, I want 31%. So what I actually now need to do is I need to work out 1%. Okay, so if 10% is 100% divided by 10, 1% is 100% divided by 100, which means that 1% of 360 is 3.6 degrees. Okay, 360 divided by 100 is 3.6. That gives me 1%. 1% of a full turn is 3.6 degrees. So now I have 108, which was my 30%. I have 3.6, which is my 1%. If I put 30% with 1%, I'm going to wind up with 31%. So 108 plus 3.6, 111.6 degrees. Okay, 108 plus 3 is 111. 111 plus 0.6 is 111.6. They would also allow you to round it up for that one to get 112 for the mark, but let's be precise with this. Okay. Question number 6. The diagram shows 3 identical isosceles triangles. Okay, so key information here. Identical means they're all the same, means I can treat them the same, means if I work out a fact for one of them, it's the same for all of them. And isosceles triangles, that means that one angle at the top is going to be different from the other two. I know my internal angles of a triangle are going to be 180 degrees, so let's put that fact up here. I need that to help me out. Other things I'm going to need to know. Angles on a straight line, okay, also make 180 degrees. Okay, that's important to know. The other thing to know is that angles around a point, however many there are, will give me a full circle. A full circle will give me 360 degrees. Those are the three bits of information really I need to know. Triangles, straight lines, angles around a point, 360 degrees. That's a mess. There we go. Okay, those are the things I need to know. Fine. What else do I know from this, looking at this? Okay, well, let's just inspect it. I know it's isosceles. There's my 40. If that's 40, that means that that's 40, which means that that's 40 because they are identical. We're told that in the question. Okay. We know that in my triangle, I have 180 degrees internally. So if my angle at the top is 40, it means I have 140 degrees left in my triangle, because 180 subtract 40 gives me 140. That means that these two corners down here, this one and this one, have to be shared equally between 140 degrees. They have to be shared equally because it's an isosceles triangle. I have one angle at the top, and then I have my two angles at the bottom are the same, but they are shared between whatever's left. If I have 140 left, because I've already got 40 up here, I have 70 in each of these. 70, 70, 140, plus 40, 180. Okay, so now we know my angles. So if let's pop in these facts here, make that a little bit smaller, and then I can drag these out here, 70 and 70 and 70, hang on, go down there, and 70 and 70 and 70. You can see R started to explain itself just by me labelling what I know. I haven't really started trying to work this out yet, but I can already see what R is going to be. I wonder if you can work that out. Let's make a 40, that's going to go up there, and pop another one of those. Pop another one of those up there. Lovely. So I've labelled my angles. Now I can work these things out. And actually, now I've done that, R and T have both kind of explained themselves if I use these two things here. Let's look at R first. For R, I'm going to need to use this bit of information. Okay, angles on a straight line equal 180. Here is my straight line. You should be able to see it. If you can't, here it is for you. Okay, there's my straight line. Okay, so for t, I've got my straight line, which must be 180 degrees total. I've used 70 degrees of that, which must mean out of 180, I've got 110 left, because 110 plus 70 is going to give me 180 degrees on my straight line. I can do a common sense check on that. 110 is an obtuse angle. Obtuse angle is greater than 90 degrees. My 90 degrees would be somewhere about there. T is bigger than that. Makes sense. Okay, now for R, I need to use this fact. Angles round a point, 360 degrees. So what I've actually got here then, if we look at this, I've got 70, 70, 70. Okay, if I add those up, that's going to give me 210 degrees. Okay, angles round a point need to be 360. So all I need to do to work out R is do 360 subtract 210, which is going to give me an R value of 150 degrees. Okay, so that there makes sense. Okay, again, double check, common sense, whatever we're saying with those. Okay, 150 is an obtuse angle. It's greater than a 90 degree angle. There's my 90 degrees. So that's greater than that. It's not a reflex angle, so it's not gone more than 180 degrees. That's fine. That seems to make sense. Again, it says not to scale. You have to reason and work it out, not measure. If you measure, it will be wrong. It will have been drawn wrong on purpose so that you cannot measure it and get the right answer. Okay, that's the reasoning that you've got to do to be able to apply yourself to answer that question. It's quite tricky in terms of thinking, but actually if we break down the arithmetic in that, what have you had to do? Okay, well you've had to do 180 take away 40. We can do that. Then you've had to do 140 divided by 2. We can do that. Then we've had to do 180 take away 70, which you can do. Then you've had to do 70 times 3, which you can do. And then you've had to do 360 take away 210. That's all you've had to do. In terms of breaking the calculations apart there, that's all you've had to do. And if you look at that, I mean, pretty straightforward stuff. The difficulty here is the reasoning and the understanding and the use of the knowledge about angles on a straight line, angles round a point, and degrees inside a triangle. Question 7. Okay, angles round a point. We know that from the last question, angles round a point, 360 degrees. I'm told everything I need to know here. I've got myself at 50 degrees, I've got myself at 50 degrees, I've got myself in here a 90 degrees, I can see that because of the way it's marked. Calculate the size of angle P in the diagram, you'll spot as well, not to scale. You say spot as well, do not use a protractor, you'll spot as well. Calculate, do not measure, it will not be correct. Okay, what have I got here then? Okay, well I've got 90 and I've got 2 lots of 50 which give me 100. So what have I got? I've got 190 degrees total so far. Angles round a point, what's my total got to be? 360, because it's a full rotation, it's a full circle. 360 degrees in a full circle. Okay, so I've got 190, I've got 360. I'll do 360 subtract 190 gives me 170 degrees. Okay, it's that straightforward. Again, common sense check. Let's have a look. Let's pop a line on here. Okay, my angle P is an obtuse angle. It's greater than 90 degrees, but it's not greater than 180. It's not a reflex, so 170 fits the bill. Okay, straightforward work there with our knowledge of angles around a point, degrees around a point. Hang on. Question 8 is hiding down here. Diagram shows an isosceles triangle and a square on a straight line. Calculate angle A. That's the only part of this question. Okay, I don't need to look at that page. I will work down here. Okay, so things to look at. Not scale, can't measure it. Fine. What to look at? Okay, so key things. Isosceles triangle and a square on a straight line. That tells us some things. That tells us that this is a straight line, good. That tells us this square is on a straight line, which means that these corners have to be 90 degrees. because it does. It's the rules. Okay, I have an isosceles triangle, which means that my angle at the top here is going to be one angle, and then my two angles at the bottom, which are going to be here and here, are going to be the same, and they're going to be shared out between whatever's left from 180, my internal angles in a triangle. Okay, the other interesting thing on this are these little lines here, this little 1 and this 1 here. That's a mathematical notation. That simply means that that is a pair of lines. Okay, the single line on it means it is a pair of lines. If it is a pair of lines in a triangle, it means that those lines are the same length. That notation, this little mark on the side of the triangle, simply tells you these lines are the same length. That means that this is an isosceles triangle, but you are already told this, which is fine. Okay, so I want to start by working out my angles down here. I want to know that one, I want to know that one on the inside. Okay, so I need to do 180 subtract 34, which is going to give me 146 degrees remaining for my triangle. That can't be both of these, but I need to divide that by 2. That's going to give me an angle of 73 for each of these. Okay, so if I pop a little 73 in here, I would put degrees in, but I don't have a keyboard shortcut, so you just have to, use your knowledge of know what they are. Okay, so let's lose that. So now here, I know that my angles on a straight line are always 180 degrees. Now, I've used 90 degrees of that, which means that I have 90 degrees left. Now, of that 90 degrees, I've already used 73 degrees, which means that A is whatever is left between 90 degrees and 73 degrees. Okay, so 90 subtract 73 is going to give me an answer of 17 degrees for angle A. Okay, 17 plus 73 is 90. 17 plus 73 is 90. Look here. '90 plus 90 is 180 degrees. That is my angles on a straight line. Okay, tricky questions, but when you break down the actual calculation, not very difficult. The reasoning is the challenging part inside these questions. I hope that helps.